All right, students. So here we are with this new assignment. Evaluate, add, subtract functions. Let's just take a look at the whole thing. So here we're plugging in some constants. Here we're going to plug in some algebraic expressions. What comes next? Perform the indicated operation. Okay. So we're going to combine these two together, simplify them if possible, and then evaluate the function. So that's a plus and that's a plus. And then we're going to add functions. So we'll evaluate each function, then add them together. Here again, adding. It's pretty simple stuff. Okay, so this one, I'll show you what to do. You're going to substitute everywhere there's a t, you're going to put a t minus 2. Okay, it looks weird, but it's pretty easy. More subtraction, so we subtract the functions from one another and then evaluate. Here we're going to evaluate each function and then subtract the results. Here we're going to, okay, now we're putting in algebraic expressions and then, so we're going to subtract the functions from one another. Pardon me. Then evaluate at negative x and then negative 4t. Okay, so I'm just checking over to make sure this is all pretty easy stuff. Okay. So on these here, we're going to substitute in 3a where we see a, okay? And then we'll figure out what that is. And then we'll subtract, well, first we'll subtract the function from one another. Then we'll evaluate at 3a, okay? Here, we're going to substitute in negative 2x everywhere we see an x. It looks kind of weird, but I'll show you what to do. Then we're going to subtract the results. All right. What I'm probably going to do is solve all of these and then cut some of them out so you actually have some work to do on your own. Okay, so let's get started with this assignment. Remember to use a straight edge. We're going for extreme clarity, and beautiful math is clearly written. So I use this little tactic here of the ruler. You know, you can use a ID card or whatever, but just draw a line, okay? And that helps us keep our equal signs lined up. So let's get into it. So what is it asking us? It's asking us to evaluate each function. So there's a keyword, and here's another keyword. All right, so evaluate a function. What does that mean? That means that we are going to take this 5, okay, and we are going to put it everywhere we see an n, okay? So we're going to substitute the 5 for the n's and then evaluate. So we'll just work this problem. The way we say this, let me make sure I've got my pen setting right. The way we say this is we say W of n, okay? So that's how you say that. Over here, it's W of 5. Okay, so W of n equals n raised to the power 3. This is n cubed. Okay, plus 3n. Just a little nomenclature. Nomenclature means like the names of things. So let's really zoom in on this and do the work. Now, what I'd like you to do in this assignment is I want you, for these problems that I show you, I want you to like perfectly duplicate what I do, because I'm trying to teach you technique and form and precision. And I know what mistakes and pitfalls exist. And so if you do it my way, it's going to make it easier for us to pinpoint where things go wrong if you do make a mistake. I recommend using lots of highlighters and colors. As you see here, get yourself a set. If you don't already have highlighters and colors, colored pencils, colored pens, whatever, make the math colorful and it'll make it more fun and visually appealing for you. So we're going to write W of 5 equals, and now we're going to put the 5 in parentheses here. And you always have to do this when there's an exponent. So we're cubing 5 plus 3, and then do a parentheses and put a 5 where there was an n. So just always put a parentheses when you're going to substitute in a value. This isn't so important for this problem, but it's going to be important for the next problem and all the problems that we do thereafter. So every time we write an algebraic sentence, we write out the full sentence. Okay, so this is a full sentence. W of n is n cubed plus 3n. Okay, the equal sign means is. So the next line is W of 5 equals 5 cubed plus 3 times 5, right? And what we just did here is called substitution. Okay, I'll just abbreviate it as sub. So now we're going to write W of 5 equals, and now we're going to do some side work. So the way that these papers are set up in CUDA, there's always a space over to the right where you could create side work. So I use a squiggly line like this. I'd like to see everybody do this. And this is our side work section. So the first side work we're going to do is this one. We're going to take the 5 and we're going to cube it. Now that is equal to 5 times 5 times 5. And it's okay if you don't know what 5 times 5 times 5 is, because you can actually section off something that you do know and then simplify from there. So we know that 5 times 5 is 25. So now 5 cubed equals 25 times 5. Now let's say that you don't know what 25 times 5 is and you don't have a calculator because you don't need one because you have a brain, right? So 25 times 5, if you don't know what it is, just perform the multiplication like you're in 3rd grade, okay? 25 times 5. I want to see this work. So 5 times 5 is 25. So we write the 5 and we carry the 2. 2 times 5 is 10 plus 2 is 12. So 25 times 5 is 125. Even if you knew this, I want to see this work. Okay. So we're going to go back to the problem and write 125 very neatly plus, now we know 3 times 5 is 15. Okay. All righty. So now we're just going to simplify this by adding 125 plus 15. And that's the second piece of side work, right? So what I would like you to do with your side work, so I know what it is, like what is the side work that you're doing, you can either take a straight edge and draw a line like this to show that we're going to do some different side work, or if you don't have that straight edge, you can just section off the side work with squiggly. So now we're going to add up 125 plus 15. Okay, 5 plus 5 is 10, so that's a 0. Again, I want to see this work, even if you already know what the answer is. I want to see the work. 1 plus 2 is 3. 3 plus 1 is 4. And then we just bring down the 1. So 125 plus 15 is 140. So W of 5 equals 140. All right, that's number 1. So I should explain what I want to see. Because we're not done. We're not done with number 1. Number 1 is going to take us a while because we're going to establish all of our habits here, and then it'll go faster. Okay, so it looks like your answer, right, that you would put down on the paper is you'd write W of 5 equals 140. But how do you know that that's correct? All right, so it's not enough in this class. This is pre-AP. It's not enough to merely write down that, okay? That's like half credit, right? So now we have to check the answer. So we think this is the answer. So like what I would say is, I would say this is like the tentative answer or the proposed answer. I mean, the question is it true, right? So is it true that W5 equals 140? And this is where we need to understand some terminology. Back up here, this 5 right here is the input value. Okay. If you're thinking about a coordinate plane, that's the x value. We also call that the domain value. Okay. And so input, x, domain. All right. So we're saying when we evaluate the function at 5, we get 140. Now, I want to show you something. W of n equals n cubed plus 3n can be written, so this is equivalent to writing y equals x cubed plus 3x. Right? The letters don't matter. The reason I like to default to this is what we call the function form. And this is the equation form. And it's actually the equation form that we're going to use to determine if we're correct. All righty. So here's what we're going to do. I got to finish explaining. So this was the input, the 5, and the output. Let's use a different color. Is the whole thing here, W of n. Okay. This is the output. We also think of that as like the Y value. And we call that the range value. Okay, so that's this whole thing. That's the whole thing. W of n is the output. So let's go back over here. That means that W of n is the same thing. I'm switching to, let's stick with all caps, is the same as just putting Y. Okay. So, we are saying that the output value, think about what we're saying, guys. This is why I'm doing this so slowly. We're saying that, let me say it, write it all out. We're saying if X is 5, then Y is 140. All right, so that's like a coordinate pair. Think about this line here, okay? So what we should see is on this line here, if I were to graph this, I should see 5, 140 should be a coordinate pair where that's the X and that's the Y, okay? This is the W of n. Sorry, sort of backwards. This is the n, and this is the W of n. All right. You probably saw this before, as this is the X and this is the F of X. But this time they're using n and W of n. Okay, this is the input. And this is the output. This is the domain. This is the range. So what I'm getting at here is, if I were to go graph this line, I should find this coordinate pair on that line. We'll get to the graph in a second. But let's jump back here. So I made this sentence here, right? W of n is the same as Y. So I'm going to use a new symbol for some of you, and that's this symbol. There's 3 dots right here. Okay, that symbol means therefore. You're going to see me use this symbol a lot, okay? So Wn is the same as Y. Therefore, comma, if W of n is 140, then Y is 140. Okay. So to check the problem, to check your work on paper without a graph, we'll get to the graph in a second. Do this. Whoa. Okay. To check your work on paper, do this. Write the original equation in the equation form. Y equals x cubed plus 3x. And now put 140 for y and 5 for x, everywhere you see an x. And what should happen is we should have the same number equal the same number. And this will mean that we are correct. Okay, so just follow the logic of it. And we will end up using a property of fundamental mathematics called the identity property of equality. So now we're going to substitute, okay? That's what this means. So I'm going to write 140 equals, remember, 5 goes in parentheses, 5 cubed plus 3 open parentheses 5. And it's a question, okay? I want to make this clear. This is a question, and so above the equal sign, write a question. In other words, is this true? All right, well, let's do the math. We already did our side work, so we can say 140 equals 125 plus 15. So 140 equals 140. Now, the question is this true? And the way that you justify it, of course, the answer is yes. But why, right? Why is it true? And the justification for that is called the identity property of equality. So we say that this is true by the identity property of equality. I'll write it all out one time, but I usually just abbreviate IPE. Identity property of equality. Okay, so that's the check. So look, the volume of work that went into getting to the tentative answer is actually a little like less than the amount of work we did to check the answer. So that's what I'm saying when I say it's like 50% of the problem is checking your work. Right, so we'll section that off so we know the difference between our work and our check. So we got to our tentative answer right about there. And then here's where we started our check. Okay, we have to check our work. And so down here, I want to see this. This is so important, right? this line right here is the verification that you're correct if you're doing the work on paper. Okay, so for this problem, I want to see all of this. And now I want to show you something cool. So I spent a lot of time discussing how you can write something in function form and then also in equation form. And the reason I spent all the time talking about that was because now we can go to Desmos or any graphing software. Let me go to desmos.com and launch a graphing calculator. All right, and now what I'm going to do is I'm going to type in this equation like this: y equals x cubed plus 3x. Y equals x cubed plus 3x. Okay, now below it, I'm going to put an open parentheses and put 5, 140. All righty. And so that point should lie somewhere on this line. So when I zoom out and go find this coordinate, it should be on the red line. And that's kind of what I was getting at here. Okay. Let me zoom out. And we know that 140 on the y-axis is going to mean we have to go kind of high up. And there's another proof that we're right. You see how that blue dot is right there on the line? That means that that domain value, 5, corresponds to that range value of 140. You see, if you go horizontally over here, you're at 140. And if you were to go vertically all the way down, it's hard to see, right? But I can show you x equals 5, y equals 140, and you'll see what I mean. The domain value passes right through the x-axis at 5. And I think I can make these lines dotted, but I can't remember how. Figure that out later. But yeah, if we go here, we see that, let me turn off the points and everything. You see, the domain intersects the range at 5, 140. And then if I get rid of that and put the dot back there, you see the line's going to pass through that point. Okay. So I'm going to save this graph and we're going to call this number 1. And the assignment is called evaluate/add/subtract functions. So this is going to be evaluate/add/subtract functions. And this is Morelli pre-AP Algebra 2. Okay, so I'm going to save this. And the reason I saved it is because now I can share it with you. And when I share it with you, I'm going to share it in the classroom. This is a classroom notebook, or at least I'll make sure that it gets into the classroom notebook. And I'm going to put it over here because it takes up a lot of space. So I'm going to paste this here and it should load it up. So it's loading up like a little version of Desmos. Okay. And so you can go mess with this on your own if you want. And if you click that link right there, it'll take you to Desmos so you can actually play with this. Okay. So I admit I spent a ton of time on number one, but this is kind of like the first problem we're doing together. And I wanted to make sure that we establish all of our habits. So we verified our problem by checking it numerically. First, we converted from function form to equation form. And then we plugged in 140 for y and 5 for x. And we solved it out. And we found out that 140 equals 140, and that was true, according to the identity property of equality. And then we graphed it, right? So then, we actually graphed it. We graphed the line. And the coordinate. Oops. It does that sometimes. Okay. So we really did do a lot of work there on number one. Now, on number two, it's really important that you follow the directions here, because when I was telling you about the directions before, I said it didn't matter so much in number one, but for number two, it's going to matter a lot. So remember, step one is we're going to put a line going through the equal sign. And we're always going to write our math out in complete sentences. So it wants us to evaluate p of x equals x squared plus 4x at p at -7. Okay, so it wants us to stick the domain value of -7 in here and find out what the corresponding range value is. Another way of saying that is it wants us to put the input value of -7 in here and find out what the output value is, which would be p of x. You think of -7 as the x value, and then whatever we get when we evaluate this will be the y value. Okay. So we'll write out p of -7 equals. Now, this is where it's so important to put the parentheses, -7, close parentheses, squared. Okay. Because if you don't put it in parentheses, you can get it wrong. Plus 4, again, in parentheses, really important here, times -7. And I just want to verify that everybody understands when we have a 4 and then like an open parentheses and then a number in a closed parentheses, we know that that means multiply. Okay, so that's like a complete sentence. You could put a period at the end of that sentence or a comma. So now p of -7 equals, all right? Well, now we need to square -7. And we're going to do that in side work because we're showing all of our work. For little problems like this, I can understand why you would be frustrated that I'm asking you to do this. But even later in this problem set, it becomes crucial. So what is negative 7 squared. Well, that's the same thing as saying negative 7 times negative 7. Now, a negative times a negative is a positive, and 7 times 7 is 49. So negative 7 times negative 7 equals positive 49. We know that anytime you square something, you're going to get a positive number. But if you didn't put it in parentheses, let's say you did this, negative 7 squared, okay? It's not clear whether you mean, okay, so what this really means, you do it just like that. This means negative 1 squared, or rather negative 1, sorry, times 7 squared, okay? That's what you're saying if you don't put the negative 7 in parentheses. So now you've got negative 1 times 49, and you'll get the answer negative 49. And we know that that's wrong, right? Because we know that when we square a number, it has to be positive. And sometimes we get lazy and we just don't put it in parentheses like we should. And a lot of times in written math, it's all understood. But if you ever put this stuff in a calculator and you don't put the negative with the 7 in parentheses, the calculator is going to tell you that it's negative 49. And if you're not paying close attention, you might just take that and move on. And that's wrong. Okay, so I wrote that out, but it's because I'm trying to show you what not to do. Okay, so don't do that. Right? So now we know that negative 7 squared is 49 plus 4 times negative 7. Well, a positive times a negative is a negative. 4 times 7 is 28. So I've got plus, and then we have a parentheses, minus 28. Okay, or negative 28. Well, what is 49 plus negative 28? It's really a subtraction problem. So P of negative 7 equals 49 minus 28. Okay, so over in side work, we're going to say 49 minus 28. Well, 9 minus 8 is 1. 4 minus 2 is 2. So 49 minus 28 is 21. So we think P of negative 7 is equal to 21. Okay, so our tentative answer is that P of negative 7 equals 21. Okay, but now we have to check that, right? So now we do our check. Check the problem. So remember, we can rewrite P of x equals x squared plus 4x as y equals x squared plus 4x. And what we're saying here is we're saying that this right here is y. So y equals 21 when x equals negative 7. So we're going to check that. So we'll write out y equals x squared plus 4x. And we're going to substitute in 21 for y and -7 for x. And what we're hoping is that the left side equals the right side. So let's substitute that in. Let's write 21 equals, open parentheses, -7 squared plus 4, open parentheses, -7. Again, for this problem, it is a bit tedious to do all this work since this is simple, but it gets very complex later on. So we already established that this is 49, and we established that that's minus 28. And we already established, because we did our side work, we know that 49 minus 20 is 21. So 21 equals 21. I just want to reinforce that this is a question, right? We don't know, is this true? Like, you know, is this true? Is really the question we're asking? Okay, and so now we can say, yes, it's true. Because of the identity property of equality. No, we're not going to do this for the whole semester or the whole year, but I want to see this. 21 equals 21. So that's part of your answer. And the other part of your answer is here, right? So these are the two things that you want to put in like a box. I'm really big on putting things in boxes. It helps me as a teacher identify what your answers are. And it helps you as a student as well. So I want to see all this in a box here, okay? So we did our check. And we verified that we were right. So remember, graphically, we can look at this as well. We could graph y equals x squared plus 4x. And then we can also, in Desmos, like that would be line 1. And then line 2, we can put -7, comma, 21. And we should see this appear as a dot on this line. So let's go back and see if that happens. Let's make a new graph. So the equation was y equals x squared plus 4x. Right, this is a quadratic graph. And the -7, comma 21 is the coordinate pair. So let's go see. -7 puts us on the left side. 21 puts us up here. Remember, we do quadrant 1, 2, 3, 4. So we expect our answer to be in quadrant 2, somewhere up here, right? Somewhere up here. Oops. So I should be able to scroll up and see that dot in quadrant 2. And there it is. Okay. So I'll go ahead and add in x equals -7. And you see that domain value fly right through that point. And then I'll put the range value y equals 21. And you see that there. Okay. Now I'll turn these off. But when I save this graph, I'll save it as number 2. Evaluate, add, subtract functions, Morelli algebra. Wait, I think I just wrote Morelli algebra. I think how do I do it? Morelli PAP algebra 2, like that. Save, share, copy. Okay, go back here, and I'll stick this one over here. Paste. Okay. When you reload this, you'll be able to see the graph. All right. And that'll be in that shared OneDrive or class notebook. The class notebook is great. It's going to make me sign in again. Okay. That's not good. Well, there is a notebook for this class. I'll work on that. Not sure why it's not showing up, but there will be one. I'll put it that way. And it will be there. Okay, so when I fix this, you'll be able to go to class notebook and you'll be able to see all my notes. And I want to show you something super cool about OneNote. So watch this. I click this little lasso tool and I'm going to lasso everything here. If it lets me. Come on, brother. Let me lasso it all. Okay, cool. Now watch this. I can hit a button called replay and it's going to rewrite everything that I wrote. Okay. I just have to find, I think that's under view. Yeah. So over here on the right, there's a button that says replay. Watch this. Oh, now it's going to make me. Okay. So I did it backwards. Now it's going to make me highlight the area that I want to replay. So let's say you want to watch me do this all over again. Watch this. It's basically playing back the whole thing. And that's one of the cool things about OneNote is that you can do the replay and actually see me redo the work. I mean, of course, you can just watch this video, but you can actually see me writing it out. What did I do and when did I do it? So OneNote is super powerful. If you haven't used it before, this replay function is probably like the killer feature for me. Like, why do I love it so much? So you can just watch that and we'll turn it off. Okay. Moving on. So now we're approaching one where we're not substituting in a constant like 5 and -7. We're actually substituting in something called an algebraic expression. And I have just a comment to make. There's some folks that say I talk too slow. And I have two responses as to why I do that. It's very deliberate. Obviously, I could fly through this math, right? Now, the reason I talk so slow is because not everybody in the class is 100% sure about all of this. Like, did you know that the technical name for that was algebraic expression? Did you know that? Right? So I talk slow so I can be very thorough in my explanations, but I also talk slow because when I upload this to YouTube, you are free to change the playback speed, and you can make it play back twice as fast if you just want to see me work through these problems very quickly. Okay. So I leave that up to the user. I talk slow because I'm not good at math. And when I say not good at math, I mean that some people are just naturally brilliant at mathematics. And I'm not one of those people. And there are a lot of people in the class who are like silently agreeing with me that they are also not one of those people where math comes super easy. Now, for some of you, you are one of those people, but you can play this back at twice the speed if you even need to watch it at all, right? So what am I going to do next? I'm going to grab my ruler. Okay. Now this time we're going to substitute in the whole algebraic expression negative 4t everywhere we see a t. Okay. So that's where the parentheses become like really, really important. So I'm going to write down h, write a little bigger this time, h of negative 4t equals, big time importance here, open parentheses, negative 4t, close parentheses, then the 3 up here in the exponent, that's called cubed, minus 4. Okay. So this is where the parentheses become really important because now we have to use our exponent rules in order to complete the problem. And so let's come over here into side work and let's review the exponent rule that goes with this particular problem. And that is called the power rule. Okay, remember, I want you to write all this down. The power rule of exponents. Okay, what is the power rule of exponents? Here's what it means. It means if I have a b raised to the power of c, that is equal to a raised to the power of c times b raised to the power of c. So what happened there? Well, what happened there was the c got distributed to each of the letters as its own exponent. Now, this is where I really need to clarify something. So let me write this again, but I'm going to write it bigger so I can make a point. A, B raised to the power of C. So what isn't ever written and what is often forgotten or not understood by a student is that when there is no exponent there is always an exponent of 1. And so what's really happening here is you're using the distributive property to distribute multiply this c times the exponents that are there, which in this case are 1. And so like the full next step is a raised to the power of 1 times c times b raised to the power of 1 times c. Okay, this becomes way important later. Right now it's kind of simple, and that's where we get 1 times c is just c, b, c. Okay, so that was the power rule of exponents. Now I'm going to shrink that down so we can actually show our side work. You writing it on your paper won't be able to shrink it down, but that's okay. Just use more space. What I like about OneNote is, oh, I didn't grab one of those little arrows, but I can shrink it down and move it to the side. Okay. Okay. I like OneNote because I can move this stuff around. I can make it smaller. What is going on? Oh. Or maybe I'm running out of memory. Stop while I'm ahead, right? Okay, so now we're going to apply the power rule of exponents to this problem here. Okay, so let's bring over into side work this -4 t cubed. So we have -4 t cubed. And what I really want to ramify here is that that's multiplication and that there's ones right there. Okay, so we're going to distribute multiply the 3 there and there. Okay, and that's going to give us this -4 in parentheses raised to the power of 3 times, I'll go ahead and put in parentheses, t raised to the power of 3. And that's where that parentheses becomes important, because that -4 raised to the power of 3 is really -4 times -4 times -4 times t cubed. Okay, so I like to do, when I've got all these to multiply, I'm going to take a couple of them together. Well, -4 times -4 is +16. So I'm going to go ahead and write 16 times what's left is -4. So times -4. Put that in parentheses. Times t cubed. What is 16 times -4? I don't know. So I'm going to do the work. 16 times 4. And whatever I get, I'll just put a negative sign in front of it. 6 times 4 is 24. Carry the 2. 1 times 4 is 4. Plus 2 is 6. So remember to put your negative sign. So it's -64. Let's go back here. So I should have been writing this out the whole time. -4t cubed. -4t cubed. -4t cubed equals -64t cubed. Okay. So now let's bring that back. That was all side work for that part. So let's bring it back. H of negative 4t is equal to negative 64 cubed. Sorry. Did not mean to do that. Negative 64 t cubed minus 4. Now, does anyone see some number that we could factor out on the right side here? Okay, here's the question I'd like you to ask yourself. What is the GCF of 64, well, of negative 64 and negative 4? Well, let's see, it's negative 4, okay? If we were to break down 64 into its prime factors, we would say it was 2 times 32, which is 2 times 16, which is 2 times 4, which is 2 times 2. And so our factor pairs there would be 2 and 32, and then 2 times 2, 4 times 16. And then we'd have 2 times 2 times 2 is 8 times 4. And then 2 times 2 times 2 times 2 is 16, right? Times 2. Wait, wrong. I'm doing it wrong. 2 times 2. I did this wrong. So I made a mistake. So this is 16 is 2 times 8, which is 2 times 4, which is 2 times 2. So I just missed that. All right, so now 2 times 2 times 2 is 8 times 8. So that's it. These are all the different factor pairs. This becomes super important when we do factoring of 64, broken down into primes. So all these are prime numbers. This is called the prime factorization. Okay. Well, let's keep going. 2 times 2 times 2 times 2. So that's 16 times 4. And then 2 times 2 times 2 times 2 times 2. Well, that should be 32 times 2. Okay. So these are all the different factor pairs of 64. And so what I'm looking for here is 64 and 4. Okay. What is the greatest common factor of 64 and 4? The answer is 4, right? So negative 64 and negative 4, the greatest common factor would be negative 4. And so what I want you to do is I want you to factor out a negative 4 from this problem. So draw a division bar or fraction bar underneath both of these terms and put negative 4, negative 4. Okay. We actually didn't list all the factors because we could have had negative 2 times negative 32, right? Negative 4 times negative 16, negative 8 times negative 8. negative 16 times negative 4, and there we would have found it. Negative 32 times negative 2. Those are also factor pairs. Okay. So let's go ahead and do this division. 64 divided by 4. What is that? There's actually an easy way to do this if you've already factored, because you can say, well, 2, 2, 16. So the cofactor of negative 4 is negative 16. So I know that when I divide negative 64 by 4, I'm going to have a positive 16 left behind. Right? Because I'm dividing a negative by a negative, I get a positive. And so let me write the next line. H of negative 4t equals negative 4, open parentheses. And now I just put positive 16 t cubed. And then what's negative 4 divided by negative 4? That's positive 1. Okay, so these are equivalent. Functions. H of negative 4t equals negative 64t cubed minus 4. And that is equivalent to h of negative 4t equals negative 4, open parentheses, 16t cubed plus 1. All right, those are equal to one another. This is the same as this. Therefore, this is the same as this. Okay? Now, the real question is, how do you check your work here? How do you know if you're right? Well, let me show you how you check your work where you have. So here is how to check when you are evaluating an algebraic expression. Okay. Because in this case, we can't use the y equals thing, all right? Because that only works when the thing inside is just a letter, okay? So this time there's an algebraic expression inside there. So we can't just put y equals and then substitute numbers and just solve it out. So here's how you check. Okay. Just pick an easy number. And we're gonna pick a few easy numbers. And one really easy number is 0. Okay. And we're gonna substitute that in to our expression and see if we get the correct answer. Okay. So first we're going to substitute in 0 for our original given expression. h of 0 equals t cubed minus 4. Okay, so we will just replace the t with a 0, and we'll see that this comes out to just -4. All right. And then we substituted in -4t, right? So we want to check our answer. We'll write the whole thing out. H of -4t equals -64t cubed minus 4. Okay, now what if I put a 0 in? So put a 0 everywhere there is a t. So h of -4 times 0 equals -64 times 0 cubed minus 4. Well, -4 times 0 is 0. So I have h of 0 equals, and then 0 cubed is 0. So 0 times -64 is 0. So I have 0 minus 4. So h of 0 equals -4. Does that make sense? Now, let's pick another number, okay? How about 1, right? So h, so this is for 0, for t equals 0. And this is for t equals 1. H of -4 times 1 equals -64 times 1 cubed minus 4. Okay. Well, -4 times 1 is -4. So h of -4 equals, well, 1 times 1 times 1 is 1, times -64 is -64. So that's -64 minus 4. So h of -4 equals -68. Okay. So we've actually come up with two coordinate pairs, 0, 4 and -4, -68. Now, the fact that we've done that means that we can now create an equation. All right. Remember this formula for slope. Okay. The slope is y2 minus, oops, I put y squared. The slope is y2 minus y1 over x2 minus x1. Okay. So we can call this y2, y1, x2, x1. Okay. So like coordinate pairs. Let's plug it in and see what we get. So y2 is negative 68 minus y1, which is 4, over x2, which is negative 4, minus x1, which is 0. And so I've got negative 72, or yeah, is it? Yeah, negative 72 over negative 4. And is 72 divisible by 4? I don't know. Let's try. Inside work. Let's try doing 72 divided by 4. 4 goes into 7 one time. And that leaves 3. And then we have 32, so it's 18. Yeah. So we actually came up with the slope. Remember, slope is m. M equals 18. All right. Well, now we have the ability, go away. Now we have the ability to use the point slope form of a line to create a linear equation that we can then test. Okay. So remember, the point slope form is y minus y1 equals m open parentheses x minus x1. And we're just going to substitute in y minus y1, which is 4, equals m, which is 18, open parentheses x minus x1, which is 0. So I have y minus 4 equals, now I'm going to distribute the 18 here and here. 18x, and now 18 times 0 is 0, so you can just leave it, or you could write minus 0, but we'll just leave it. And now to get y by itself, I just add 4 to both sides. Okay. So y equals 18x plus 4. So look what I've done now. Now I've created a line. Okay. Now what we're suggesting here is that if I were to graph that line in Desmos, both of these points would appear on that line. Okay. So let's go see if that is actually true in Desmos. So 18x plus 4. I want to create a new graph. Y equals 18x plus 4. Okay. And then I have 2 points that I'm checking. 0, 4 and negative 4, negative 68. So 0, 4. That appears there. That's good to know. And then negative 4, negative 68. And where will that be? So both of them are negative. That puts us down in quadrant 3. So I'm going to be way down here. And there it is. Okay. So let me share this with you. I'll zoom in on this one. Okay. And we'll go ahead and share this one out. I got to name it first. Save. Sorry. So this was number 3, right? Yep. Number 3. And the homework assignment is called Evaluate, Add, Subtract Functions. And this was Morelli pre-AP Alg 2. Okay, save. So that's saved. And let's share the graph. And we'll put it over here, like right there. Okay. So take a look at the work so far. And ask yourself, does this look like the work that you have previously done in math? And my guess is no. And that's not I'm not attacking or dismissing or in any way I'm denigrating your previous teachers. It's just that the last time you took an algebra class, you were preparing to take the STAR test. And now we can, the reason I love Algebra 2 so much is we can finally learn the actual algebra behind it instead of having to rush to hit all those teaks to get ready for that STAR test. Okay. So let's go to number 3 here. I was just OCDing out that I didn't put that line. So we got to our tentative answers here. So we think now we know they're right? So we checked it. We can put them in boxes. By the way, which one do I prefer? Okay, that's a good question. I prefer this fully simplified version. So the answer that I'm going to be looking for is, am I ever going to be able to make it bigger? So what's happening is the memory on the computer is starting to spaz out on me. So I have to make it bigger like this and then move it. So I want to see that one where you factored out the greatest common factor. So just so you know what my class expectations are, always factor out GCF when possible. Okay, so if you just turned in this, that's okay, but I would probably sit down with you and tell you, okay, here's what I want you to do. And after a certain amount of time, this will not be given credit. Okay. What I want to see is I want to see that. Because sometimes we want to see it this way, but but a lot of times we don't. So at the beginning here, I'm not going to be so discriminating, but if you see an obvious greatest common factor, you might want to give both of them, right? So maybe what we should do is, I can't select this shape anymore, but maybe what we should do, I can select it with the mouse. Maybe what we should do there is write down both of them, okay? Because they're both equivalent. And then we have the check down here. So let's get our ruler out. And check right here. Okay, well, this has gone on. We've gone on for quite a while here. And I can tell that the computer memory is running very low. So I'm going to stop here at number 3. And we'll make this a multi-part video. Okay. So let me end the Zoom. I'm trying Zoom because I've noticed that this memory problem with the computer, when I'm using this software down here called OBS, it's really hogging the resources of the computer. And I'm noticing that the computer freezes up. And I can't wait. I'm using a Surface Pro 7. That's what this device is. It's not an Apple or anything. But I'm waiting for Surface Pro 8 to come out because I'm guessing it's going to have better hardware on it, better graphics, and it won't have this problem where it gets too hot and freezes the screen. So let me end the Zoom now. I'll stop sharing. And we'll pick this up in a second recording.